Hello, friends, a podcast to go over the third concept from section 2.2 in the AP Stats book. Now we're going to apply what we've learned about z-scores and the normal distribution to percentiles. So, going back to this previous example, if I want to know what percentile the score of 16 is in this distribution, I identify where 16 would end up in the distribution. So here's 17, here's 14, so 16's got to be a third of the way in between. And if I find the area to the left of this number in here, that is going to be my percentile. So I can simply calculate the z-score, 16, which is the random variable I'm interested in. 17 is the mean divided by the standard deviation, and that's going to give me negative 1/3. Which is negative 0.3 repeating, and then I go to the table, and this time I don't have to go way down to the bottom, but I know, here's my 0.03, so I'm going to be in this column, and if I go all the way down to the bottom and find the negative 0.3, right here, and continue down, I get an area under the curve. Again, this area right here for this score is going to be this 0.3707. So that means that this score is in the 37th percentile. So now pause the podcast and you do the percentile for number 20. You can tell me what you got tomorrow in class. Let's look at an example. So here we are, problem 53 in your book. Let's pull out the most important information. Again, reading the question carefully, I can see that this is a normal distribution of the length of human pregnancies, and that the mean is 266 days and the standard deviation is 16. And they ask me here, what is the percentile for 240 days? So that is now the random variable of interest. So I calculate a z-score, x minus the mean, divided by the standard deviation, and I can see, and that's going to give me an z-score of negative 1.63. Now let me start hitting you with some new notation. So what I want to find this percentile is the probability that I get a z-score less than or equal to negative 1.63. This means, what's the area under the curve to the left of the z-score negative 1.63? So back to my table. Here's my 0.03 because it's negative 1.63. I slide down till I find negative 1.6. I come over here and I've got 0.0156. So rounded, that is going to be the 5th percentile. So there you have it. Now, of course, we have a calculator program that will do the same thing for us. The program this time is z-score. And in my list, that's number 5. So I hit program, number 5, enter starts it, and I can type this z-score in just the way it appeared. My random variable of interest is 240, all in parentheses, of course, minus the mean, which is 266, and close them, and divide by the standard deviation, which is 16. And when I hit enter, it tells me the z-score, and notice the ant's marching, it's waiting. Now that I've written that down, I hit enter. So this tells me how much area is to the left of that z-score, how much area is to the right, and the percentile. So this means that 94.79% of the births are longer than this, 5.21% are shorter, and that means that's 5%. So let's wrap up these last two parts, make sure we're paying attention here. So I want to know what percent of the pregnancies are between 240 and 270 days. Well, that means I'm going to find the area under the curve between these two z-scores. But that's the Norm-Win program from the last podcast. Program key, Norm-Win is 3 in my list, and hit enter, and you're going. When they ask me for the low, I put the 240 z-score in. For the high, 270. When I hit enter, it's going to draw it out for me, and it's going to tell me that the number of pregnancies between those two are about 55%, 0.5466. Part C we'll answer in the next podcast.